Okay, so I have this one. This is slide 7. Am I right? It's like, yeah, slide 7 from 1.7. And so we're going to do this one. This is actually a really good one to do right after slide 6, ordered appropriately. So here, this one says, is this arithmetic? It's the same exact setup, but now we're going to do it on this one. This one is a little different. So the very first thing that I do, what's the very first thing? Yeah, exactly. What's the very first thing that I usually do whenever I'm given this kind of information? What's the first thing I should do? Yes. For this one, I'm like, what? I'm going to look at this table. And then I'm going to try to determine whether it's arithmetic or geometric. Okay, I'm going to pretend I am a student right now. So the very first thing I like to do is subtract. So I'm going to go 10. Oops, sorry. This is 5. This is plus 5. And this is plus 10. Okay, so Ms. Johnson, this is plus 5. This is plus 10. This actually means what? This is not arithmetic. Okay. So I'm going to cross off arithmetic. Nope, you're not arithmetic, right? Because that was not a constant difference. Okay, so then I'm going to erase all that. Okay, let me try again. Let's see. Let me try multiplication. So this is times 2. This is times 2. And I'm like, yes, I figured out my pattern. Miss Johnson, how did you know that it was times 2? I was just playing with numbers in my head and I said, how can I get from 5 to 10 by not adding, but by multiplying? So I said, oh, times 2. And then I brought that down again times 2 and I got 20 and I brought it again down 2 and I got 40 and I'm like, yeah, that's it. Yes, and you can divide as well. So you can say 10 divided by 5 is 2. 20 divided by 10 is 2, 40 divided by 20, and so on. Okay, so I'm very excited because this guy here similarly tells me I am geometric because I'm multiplying. So I'll put here multiply as your little reminder, right? The second thing I'm going to do is someone called this the common ratio. Let's see, let's write that down in this color. Common ratio. I've also heard it be called multiplier, which I also like. So either way that you call it, I want to label this guy so that you feel a little bit more comfortable with where he's going to go. So similar to the one that we did up here, and I wrote plus 12, plus 12, plus 12, and all the other 12s that showed up everywhere. I want to kind of do that here. Okay, so here with geometric, to find the next term, yeah, I'm going to talk about this because this is going to be multiply by 12, right? The recursive equation is going to have a times 12 as well. The nth term is also going to have a times 12 as well. And yes, the explicit equation is going to have a times 12 as well. Ms. Johnson, you can, oh, why am I putting 12? Dang it. See? Thanks for having my back, Johnky. I appreciate you. I'm just going to pretend that I didn't do that. But not really, because I know my mistake is making me stronger. So I'm okay with it. Thank you, thank you, thank you for having my back on that. I appreciate that. So times 2 times 2. Oh, that's why, because I was over here in the plus 12 land. Boo, Miss Johnson. Okay. So times 2 times 2 times 2 times 2, all over the place. Man, it's like he's the star of the show this time. Yeah. So just like over here, our slope was the star of the show. We see him here and here and here and here and here. We see him here and here and here and here and here. Okay, moving on. Okay, so we're done with this part. It's geometric. How to find the next term. We're just going to multiply by 2 to the previous. And maybe I should write multiply. So let's put that in parentheses. Let's use another color. Multiply by 2 to get next term, right? Oh no, you were doing so well. And now you're having syncing issues. Okay, so imagine it says multiply by 2. My recursive equation, okay? Your recursive equation, again, it has two parts. Number one, where did it start? Can you give me my starting point? Can you give me my starting point right here? What's my starting point? What's my starting point? Very good. Very good. I got lots of 5s, Miss Johnson. Exactly. So I'm going to write my starting point as f of 1 equals to 5. Very good. And again, I didn't leave myself enough room, so I'm going to scooch you over. Okay, the next part is always going to be that f of n equals to f of n minus 1. So I'm going to write that. F of n meaning the next term is equal to the previous term, f of n minus 1 times 2. Now, that's like this is in English, and then this is in function notation in math language, right? So is this okay with everybody? So far, so good. Just multiply by 2 to the previous one? So is this structure going to be existing for all of our geometrics? Yes. And this structure will work for all of our arithmetics? Yes. Okay. Then it says to find the nth term. So hold off on this one because that one's our new guy and I want to like type them all out so it's nice and clean. Our explicit equation, if you remember, I've been writing out all of our terms like this, right? So I'll write it over here to the left just because I want to actually, where will I put this? I'm going to move this over here. Actually, I have an idea. Let me take a picture of this. And then I'll move it over as well. Just this little guy right here. So I'm going to copy and put it right here. Okay. Okay, so I'm going to rewrite our terms with that times 2 times 2 times 2 business because that always helps me. So 10 is really my 5 times my 2. 20 is really my 5 times 2 times 2. 40 is 5 times 2 times 2 times 2, right? Right, so here what I want to do is I want to write my things in terms of my, like with an exponent. Can you try that out for me? Can you try writing your geometric equation right here for me? So if you're wondering what I'm talking about, I'm asking you what stays the same. Oh, Ms. Johnson, I see that 5 and the 2. Very good. 5 times 2, good. 5 times 2, good. 5 times 2, good. Now, what changes is how many factors I have. So I need an exponent here, right? So here I only have 1. Here I have 1, 2. Here I have 1, 2, 3. And then again, I'm always playing with this thing in here. Like, how is this number here related to that 1? How is this 3 related to that 2? How is this 2 related to that 1? How is that 3 related to that 2? Yeah, very good. So someone said in the chat, Ms. Johnson, it's going to be this 5 times 2 to the n minus 1. Now, if you're not convinced that it's n minus 1, I want you to focus in on this little part here. This 3, when you look over here, I only have 2 factors of 2. So it's not n at all, it's n minus 1. Okay, hold on. For some reason, it is super slow. So can you pretend? Oh, there it is. Yay. Okay, so 5 times 2 to the n minus 1. Ms. Johnson, does it have to be n minus 1? In this case, yeah, right? Because I don't want to use the same number. This 4 right here isn't that 4 right there. Those two numbers aren't the same. It just went down by 1. So how do I say down by 1 in math language? Minus 1. Oh, so that's my equation right here? Yes. So I'm going to copy that over here. So 5 times 2 to the n minus 1. This is going to be f of n. right? And the part I know that you're curious, you're like, Ms. Johnson, well, what about that part? Like, how do I write this? How do I write to find the nth term? Well, here in this case, we're not starting with 3 and adding 12 n minus 1 times. So what are we doing? Let me grab this structure real quick. So what I am doing is I am starting at 5. I'm not adding, am I? What am I doing? Yeah, I'm multiplying. So multiply by 2. Now, how many times am I going to multiply it? Oh, well, you already told me n minus 1. Oh, okay. So write n minus 1 here, Ms. Johnson? Yes, please. So you're going to multiply by 2 n minus 1 times. So just to prove that, when I was here at 4, I multiplied 5 once, twice, 3 times. Yay! Right? 3 times. Okay. So that's how I got my answer of this. Okay. Again, which is the weirdest part for this one? And then just that's where I want you to focus when you work on 3 and 4. And then I promised that I would do 5 right now. Yeah, the nth term is still really weird, right? So just think when you're doing that part, what I want you to think is, how did I get here? Well, I started with 5 and I multiplied by 2 3 times. How did I get here? I multiplied by 2 3 times. 1, 2, 3. I know, that's cute. I like that. I like that phrase. I promised that I would do 5 right now. So let me do that really quick. Again, I'm gonna start off exactly the same way every single time. I'm gonna start off thinking, oh, this is gonna be what is it called? Arithmetic. So I go +1, +3. Wait a second. So automatically +1, +3. Boo! It's not arithmetic. Okay. Okay. I got it. So let me try multiplying. Oh my gosh. I don't know 3 times what gives me 4. So I'm going to go with my divided by. I'm going to go with 4 divided by 3 is 4/3. But 7 divided by 4 is not 4/3. So 4 divided by 3. Give me 4/3. 7 divided by 4. Yes, very good. Yes. Yes. Okay, very good. Okay, so it's not very good. Sorry. Good job. Very good. No, I understood exactly what you said. Okay, so this is 4/3. 7 divided by 4 is 7/4. So wait, Miss Johnson, it's not arithmetic and it's not geometric. Exactly. It's a neither. It's a neither. Now, remember in the very first part, oh, and you figured out the next term. Awesome for you. Very good. For if you read the directions in the very top, once you figured out that it was neither, you weren't supposed to answer any of these things. So if you found the next term, awesome, really good job. But Ms. Johnson, can a sequence be not geometric or not arithmetic? Yeah, there's actually a lot of different sequences out there besides arithmetic and geometric. These two happen to be the most popular. Very strong work. Very strong work.